In 1996, NVIDIA had just enough cash left to survive about one more month. Its first major product had failed. Its biggest technological bet was wrong. More than 70 graphics chip companies were fighting for the same market, and almost all of them would disappear. Inside a small office in California, Jensen Huang faced a brutal choice: keep building the company's flagship chip and slowly run out of money, or admit they had made a catastrophic mistake, scrap years of work, and gamble everything on starting over. Either decision could end the company. Today, NVIDIA is worth trillions of dollars and sits at the center of the artificial intelligence revolution. Its chips train the world's most advanced AI models. Every major AI company, from OpenAI to Meta, Microsoft, Google, Amazon, and countless startups, depends on technology that traces its roots back to those desperate early years. But none of this was inevitable. In fact, one failed graphics chip, one unlikely investor, and one extraordinarily risky decision almost erased NVIDIA from history forever. This is the story of how NVIDIA nearly died before becoming the company powering the future of AI. The beginning. NVIDIA was founded on April 5, 1993, by Jensen Huang, Chris Malachowski, and Curtis Priem. At the time, the personal computer industry was changing rapidly. Games were becoming more complex. Three-dimensional graphics were no longer science fiction, they were becoming the next computing revolution. Most people saw graphics chips as simple accessories. The founders of NVIDIA saw something much bigger. They believed graphics processing would become one of the most important forms of computing. It sounded ambitious, maybe even unrealistic. There was just one problem. Nearly everyone else was chasing the same opportunity. When NVIDIA was founded, roughly 24 companies were building graphics chips. Within only a few years, that number exploded to around 70. The odds of surviving were terrible. The odds of becoming the industry's leader were almost zero. Like every startup, NVIDIA had to ship a product before it ran out of money. Their answer was the NV1. Released in 1995, it wasn't just another graphics card. It was radically different. While much of the industry was beginning to standardize around rendering graphics using triangles, NVIDIA chose an unconventional approach based on quadrilateral primitives. The company believed this architecture would prove superior. Instead, it isolated them. Microsoft's Direct 3D ecosystem moved toward triangles. Game developers followed Microsoft standards. Suddenly, NVIDIA's technology looked increasingly incompatible with where the industry was heading. Technically impressive didn't matter if nobody wanted to build for it. The NV1 struggled commercially. For a young company with almost no financial cushion, failure wasn't simply disappointing. It was existential. Most startups never get a second chance. NVIDIA almost didn't either. Around this time, Sega was searching for advanced graphics technology for its future gaming ambitions. The partnership offered NVIDIA something far more valuable than publicity. It offered time. Sega invested approximately $5 million into the young company. Years later, Jensen Huang would repeatedly describe that investment as the reason NVIDIA survived. Without it, he has said, NVIDIA likely wouldn't exist. Ironically, the graphics technology NVIDIA was building ultimately wasn't selected for Sega's Dreamcast console. From a business perspective, the project was disappointing. But financially, the partnership kept the company alive long enough to make another attempt. Sometimes survival comes before success. Money bought time. It didn't solve NVIDIA's biggest problem. Jensen Huang and his team realized something almost impossible to admit. Their strategy was wrong. Years of engineering had led them toward an architectural dead end. For many founders, this is where pride becomes fatal. Instead of defending their previous decisions, NVIDIA abandoned them. They threw away much of their existing work. It was painful, expensive, humiliating, but it allowed them to build something customers actually wanted. Years later, Huang reflected that the company faced a choice between finishing a product that would fail slowly or stopping immediately and starting over. Neither option guaranteed survival. One simply offered hope. That hope became the Riviera 128. Released in 1997, it wasn't merely another graphics chip. It represented a completely different philosophy. Instead of fighting industry standards, NVIDIA embraced them. The market responded almost immediately. More than 1 million units were sold within the first 4 months. OEM manufacturers rapidly adopted the chip. For the first time, NVIDIA wasn't just surviving, it was competing. The graphics industry during the late 1990s was ruthless. Companies like 3DFX, S3 Graphics, Matrox, ATI, and many others fought intensely for dominance. Every generation of hardware required massive engineering investment. One failed product could destroy years of progress. Many competitors disappeared. Some were acquired. Others simply ran out of money. NVIDIA kept moving. The company introduced increasingly powerful graphics processors, shortened development cycles, and built strong relationships with game developers and hardware manufacturers. Then came another defining moment. In 1999, NVIDIA introduced what it called the Graphics Processing Unit, the GPU. It wasn't just a marketing term. It reflected a shift toward programmable, massively parallel computing. At the time, almost everyone viewed GPUs as gaming hardware. Very few imagined they would eventually become the engines of artificial intelligence. If GPUs were so successful in gaming, why change anything? Because Jensen Huang believed graphics processors could solve problems far beyond video games. In 2006, NVIDIA introduced CUDA. CUDA allowed software developers to use GPUs for general-purpose parallel computing instead of only rendering graphics. Initially, adoption was slow. Writing GPU software required new skills. Many businesses didn't see the need. Some questioned whether the investment would ever pay off. But researchers noticed something important. Certain scientific calculations that took CPU hours could be completed dramatically faster using GPUs. Universities adopted CUDA. Scientists adopted CUDA. Then machine learning researchers started experimenting with it. That quiet decision would eventually become one of the most valuable software ecosystems in computing history. For years, CUDA looked like a smart niche investment. Then, in 2012, something remarkable happened. Researchers at the University of Toronto trained AlexNet using NVIDIA GPUs. The model dramatically outperformed previous image recognition systems and became a defining moment in modern deep learning. Suddenly, GPUs weren't just graphics processors anymore. They had become AI accelerators. Over the following decade, deep learning expanded into speech recognition, recommendation systems, robotics, autonomous vehicles, and eventually generative AI. Each breakthrough demanded more computing power, and NVIDIA had spent years preparing for exactly this moment. While competitors focused primarily on hardware performance, NVIDIA had built something much harder to replicate: a complete software ecosystem. Developers already knew CUDA. Companies had already optimized their applications. Switching away became increasingly difficult. Then came ChatGPT. Almost overnight, artificial intelligence became the biggest technology story in the world. Training large language models required enormous numbers of GPUs. Cloud providers rushed to expand data centers. Technology companies placed orders worth billions of dollars. NVIDIA suddenly found itself supplying the world's most valuable resource in AI infrastructure. The same company that had nearly collapsed because of one failed graphics chip now occupied the center of an entirely new computing era. Its customers weren't just gamers anymore. They were governments, universities, cloud providers, pharmaceutical companies, automotive manufacturers, and nearly every company building advanced AI. The transformation looked sudden. In reality, it had taken 3 decades. It's tempting to explain NVIDIA's success by pointing to brilliant engineering, or exceptional leadership, or perfect timing. The truth is more complicated. Timing mattered, engineering mattered, leadership mattered. But what truly separated NVIDIA was its willingness to abandon bad ideas before they became fatal. The company didn't survive because it never failed. It survived because it recognized failure early enough to change direction. Its first flagship product failed. Its architecture failed. Its assumptions failed. Yet each setback forced NVIDIA closer to the future it would eventually dominate. Jensen Huang has often spoken about enduring pain, embarrassment, and setbacks as unavoidable parts of building the company. Looking back, those moments weren't interruptions to NVIDIA's story. They were the story. History remembers NVIDIA as the company that powers artificial intelligence, but history almost remembered something very different. Another ambitious Silicon Valley startup that built the wrong product at the wrong time and quietly disappeared. One investment from Sega, one painful strategic pivot, one decision to throw away years of work instead of defending a mistake. Those moments changed not only NVIDIA's future, but arguably the future of computing itself. Today, every breakthrough in AI reminds us of a simple lesson. The companies that change the world aren't always the ones that get everything right. Sometimes they're the ones that survive long enough to get one truly important thing right.